Hello. I thought we would cover something that was a rite of passage back in the day, which was compiling and running your own Linux kernel. I guess just to go over my history is that I started using Linux back in 1992, back when it was the boot and root floppies. It was kind of exciting, but there wasn't a lot to do because you had to build everything. And part of the thing you had to do in order to get a system going was you had to install this operating system called Minix, and then somehow find a way to get source code onto there, and then build the compiler, and then cross-compile. It was a lot of work. It was a lot of work. Or you could just download and run a ready-to-be-made kernel. But back then, we didn't have a lot of memory, so one of the first things that you would do is build your own custom kernel. So that way you could get rid of all the stuff that you don't need. So that brings me to this thing I did a long time ago, Ancient Linux on Windows. So it's not just emulation. It starts out with basically I ported the compiler, the assembler, the general build utilities so that you can actually compile ancient versions of Linux on Windows. I'll put the link into the description. It's very easy, just source forward projects, Linux 011. Oh, great, trending news, who cares? Anyway, or just hit the download button and that'll take you there. This is an old project I had years ago, so that's why it's on SourceForge. I guess I could put it on GitHub, I really don't care. You know, most of these changes were just to make the thing run on Windows. So anyways, you would just click here, hit the download button, and then it will proceed to download. Hooray. We don't need to because I already have a copy downloaded. Oh wow, yeah, I guess I should shill for myself. I do have a Patreon page. You know, taxes take a huge cut. That's why the low tier is $4.50. I know, I'm sorry about it, but I try to update often. You know, give some stuff for feedback, and it really helps. But anyways, I know people don't like the ads. And of course I do have a page on Archive where I try to keep all my latest and greatest stuff up to date. I would highly always recommend checking out here because there's all kinds of fun things. And of course my blog, which, you know, well, I've been doing that for quite some time, 2007 in May. Wow, that was a long time ago. Alright, well, enough of the web pages. Once you have downloaded this thing, I'm going to go ahead and we're going to extract it to the root of the C drive. Why? Because why not? This will take just a few moments. I guess depending on how fast your machine is, whether it's a physical hard drive or NVMe. Unfortunately, I just remembered this virtual machine that I'm capturing from, it's on a spinning hard drive. So this will take a moment. I might just fast forward this part.
2 hours later.
Alright, and we're done. So now we have our new directory extracted out. We can explore real quick. So the big thing on here is I've included the source code for the tools. This is all the various versions of GCC, GNU Debugger, the 16-bit Linux 86 tools, version of QEMU, curses for console manipulation. I think I needed that for GDB. Bison, which parses text, and then binutils, which is the like the linker and archiver and stuff when building programs such as Linux kernels. Going into the source directory, you can see this is the various versions of the Linux kernel that I've prepared. 0.1 is not a real kernel, it's a reconstruction from the old Linux guy. Actually, I guess I should bring that up. This is a great resource for anyone interested in the old days of Linux. I thought it was oldlinux.com. Well, anyways, I do keep a mirror of it. oldlinux.superglobalmegacorp.com. There we go. I'll keep a Again, links for all this stuff in the description. But this is a great resource for old versions of Linux, and as you can see, yes, I know about it because I helped make it possible. I don't know why, but a lot of this old stuff is basically lost to the winds of time. But you can find the 00 images that I built, and then from there, their reconstruction. And actually includes like some good information as far as the stuff available at the time. It's a lot more technical than I wanted to get into this. But for now, what we're going to do is we're going to build the 0.10 kernel. Now the one thing that's nice about this is that we're on the Windows file system. We've only extracted the zip file. We haven't built anything yet. So if I wanted to look at the main part of the kernel, I can go ahead, right-click and edit, and then I can edit this as a simple text file. So you don't have to go through subsystems, mounting disks, or any of this crazy stuff. So the source code is directly accessible right from your Windows PC. So if I were to go in here and just say, let's go ahead and add a message, print K, what's today? So today's the 6/11/2024, hello, and then new line, great. So now we've modified the Linux kernel. So we can tell then once we boot it up that it's actually going to be this one. So to compile, first thing we need is a command prompt, or you can just go start with run cmd and cd to the a.out directory in the root. I've tried to make this somewhat simple to run, so you should just be able to type in this batch file env, and it will set the environment for the compiler. So we can type that in. You'll notice the title bar has changed, and now we can type gcc -d, and that will start the compiler just to tell you what version the compiler is. Now we're going to go into the source directory. Remember, this is where we were back here, so we're going to go into Linux 10. If you like this shortcut, you can type in cd here, go back into here, grab this folder, drag, drop. Wow, wasn't that great instead of typing? Yeah, maybe you learned something. Maybe not. So, I already have a pre-compiled version right here, but we don't want that. So, I'm going to go ahead and delete the image. So now there's no pre-compiled kernel. Everything's actually all pretty much set to go. So you should just be able to type in make, and then it will start the compiling process. Building under Windows is substantially faster than it was back in the day. And as you can see, we're already done. It takes next to no time. Let's see if we bring up Task Manager just to give you an idea of just how much or how little strain this is on a modern machine. I'm going to do a make clean, which undoes the make process. So this will delete everything we just did. Scroll this down so we can watch this in action. Just type in make. And here we are, we're compiling. We can watch the CPU. And it's done. You can watch the CPU graph collapse. So, yeah, it's amazing how fast modern machines are. Okay, so we've compiled a kernel, that's great. But what about actually using it? So again, I've tried to make this somewhat easy. There is a QEMU directory, which is a very popular user mode emulator at the time. And I've tried to make this again, all ready to run. So you should just be able to double click on this. And here we are, we're booted up, and as you can see, it's the one I compiled with a 6/11/2024 message. Isn't that great? So here we are on a virtual machine, all with our pre-configured file system. There's not much on here. There's a version of GCC on here. It is the 1.4.0. This is, again, going back to the Linux days of 92, 93. There is no shutdown. There is no reboot command. You just would run sync a bunch of times, pull the plug, and hope for the best. So, hopefully this kind of like shows you that, you know, building software that's at least configured, you know, it's really not that scary. It's, you know, granted, of course, I did all the hard work behind the scenes. So this will, you know, basically just work. So if you want to try another version, let's try the Linux 109. Let's CD to it. Run make clean. And again, you can see that these make scripts, you know, they're very inefficient. Alright. So now I'm going to compile a much more complicated version of Linux. So just type in make, hit enter, and now we can watch them execute side by side. And you'll see that this uses a newer version of C compiler. It's a lot more features, but even then, we are done compiling. And to run this kernel, just like the last one, back into this directory, the a.out gcc qemu directory, there is a Linux 109 command prompt thing. We can just double click, and here we are booting straight into the Linux we just compiled, just like that. And here you can see that it was compiled on my random desktop here, June 11th, 2024. Log in as root, no password. And here we are to a different computer. I forget why I use different image. I think it might be the file system type. Again, this is very old stuff. I just went for small disks, and it just had enough Linux to run it. It's not meant to be usable. You know, again, I was just more so interested in compiling and running Linux. If you click in the window and it grabs the mouse, you'll notice here it says press Ctrl-Alt to exit grab. So the Ctrl-Alt key on the bottom of your keyboard will release your mouse in case you click in there and get stuck. I guess as a revision, I might almost look at rebuilding it so it can't grab the mouse, because we really don't need it. Let's see, there's the 2 hard drive images. You know, again, you could re-extract them from the zip file if things get wrong. They're not real, so it doesn't matter. I guess one thing to explain about the source code for all of these versions is that you will see that it makes this file called image, and this image is actually a bootable floppy image, because back in the day that's how you actually were expected to boot Linux. Yeah, because booting from a hard drive was it was a big secondary effort. There was ways to do it. There was the bootloader called Shoelace, and then the one that was more popular that I used was called Lilo, the Linux loader. And it was a fantastic way to overwrite and destroy your hard drive, because, you know, this wasn't the tested world of Microsoft. This was, you know, the Wild West of, you know, it works on my computer, so it should work on yours. And yeah, you know, this is the thing. In many ways, nothing has changed in the world of Linux. You still run into the same problem. You know, if it works on my computer, well, we'll just ship my computer, you know, and Docker was born. Hooray! If you try to type the file, you'll just see it's a lot of garbage, but you can see the text strings, and again, here's the compiled by my hello world, which is kind of cool. I don't think there's a strings command in here. No. There's file command, so you might be able to run file image, and it will tell you that it's an x86 boot sector. Because again, the kernels that it compiled were basically floppy disk images. You would write these things to floppy disk, and then, you know, it has just enough code for a floppy disk to pick up boot, load the kernel, and then the kernel is in turn hard-coded to use the root from the hard drive. Let me build this kernel one more time. So you just run clean, run make. This used to take forever back in the day. But here you can see that it's setting the root device to 3,1. So this will be the hard drive. I guess just to show what I'm talking about, just fire up Notepad. Let's capture this. then we go back to our QEMU. Let's run Linux 010. So we're going back to running our kernel. I guess we had a problem. Sometimes, Linux being Linux, it's not perfect. So just close the window, try again. Okay. So all the devices in Linux, or any Unix, are represented as files. And each file has a type. It's either a block with a B or C for a character. So block devices are things like hard drives, floppy disks, things that you read basically one block at a time. There's sectors. You're not just transferring a single byte at a time. But when you're typing in and out, your keyboard, your screen, believe it or not, because it's emulating what they call a teletype, it's a character device because you can only read or write one character at a time. So that's why you'll see it has TTY devices. They're virtual teletypes like all Unix, and they start with a C for character devices. And our hard drive, HD0, is a block device. So HD0 represents the entire hard disk, starting with the partition table and the whole device being raw. But you'll see HD1, which is 3,1, which goes back to here. Root device is 3,1. HD1 represents the first partition on the hard drive. I don't know if there's an fdisk command in here. Oh, there is actually. That's nice. Can you print the table? There we go. So this kind of helps visualize it too. So the HD01 is the first Linux partition on the hard drive. If I quit out of here and again, -L HD01, HDA1, right? No? My mind's already going. Just HD1. Because over the years these things change. And it can be a little hard to remember from time to time, but you'll see again. The big thing is that this is a block device, 3 being the major number, 1 being the minor number. So you'll see, again, all these hard drives have the major of 3. So just because you're not going to actually see this many hard drive partitions, but in the off chance it'll create device nodes for each one. It gets a little complicated, but the upshot is that until they had a device driver file system that was configured from the kernel, you didn't know what file nodes here would interface with the kernel, so you would end up with tons of extra files. And then just like compiling your own kernel, you would tend to delete all these files that you didn't need, so that you would save actual hard drive space, because back then disks, memory, CPU was not cheap like it is today, so you wanted to save as much of this stuff as you could for yourself. So that's why you would remove all the stuff you're not using, because it actually would save space, because this is a record on the hard drive. Well, I think that's 20 minutes, not bad for just a quick recap. Just enough to, I guess, show you that you can in fact actually quickly and easily compile a kernel. If you want to keep your hard drive in any sane state, remember there's no shutdown command. You literally just run sync a bunch of times and then close the window. It really was that bad back then. Data loss absolutely was a thing. You always had to keep backups of anything you wanted or anything you valued to a floppy disk. But this is all emulated. It doesn't matter. You're not going to lose any major data. And of course, again, the major goal was to be able to house on the Windows file system source code for various Linux kernels, and then be able to build them from within Windows. I guess that's about it as far as that goes. So I guess if you have any questions, just leave me a message down below. Otherwise, I will see you all later.